Hi everyone! Welcome to the Swift preview of Precalculus, which as you'll see is named this because Miss Swift wrote our textbook, believe it or not. So we are covering what we want to pick from chapter 1 of that textbook. So we're kind of incorporating several chapters per, kind of made up units here. And chapter 1 is all about equations and inequalities. So we're going to sort of cherry pick some key bits of information that we want to maybe review, maybe go over for the first time regarding our equations and inequalities. Namely, the big piece here that we want to walk away with is the empty set or null set versus all real numbers. So we can have equations and inequalities where either the empty set or all real numbers can actually be the solution. So let's dive into that. Let's talk about how we run into those. So if we are solving an equation or we're solving an inequality and we reach the end and it's a false statement. So for example, something like 2 equals 5, where obviously that's not true. If that happens, then the equation or inequality has no solution, is what we often say. We can also say, though, that the solution set is called the empty set, or I tend to hear more often the null set, null just kind of representing there's nothing there. And we write that as our solution is equal to, so x being what we perhaps solved for, the null set. This little like circle with the line through it means the empty set. There's nothing there. So that happens anytime we reach a false statement. So of course the other option, well, besides solving for x and getting x is equal to some number, the other option is to have all real numbers. So if we have all real numbers, then that means in solving our equation or our inequality, we've reached some statement that is actually always true. So some true statement, for example, like 3 equals 3, 0 equals 0, x equals x also represents all real numbers. So if we determine that we have a solution of all real numbers, we write that as x equals, this is our symbol for all real numbers. So I tend to write that as like my big capital R with an extra line through it. Unless you're typing, in which case you can actually find this lovely little character. So that represents all real numbers. That's all numbers that are integers, all numbers that are whole, all rational numbers, etc. Basically just not imaginary numbers. Let's look at a couple of examples where we run into situations like this. Okay, here's a couple. One is an inequality. So we're going to go through how we work with inequalities, and it's very similar to working with equations. We just have a different symbol separating our two sides. So in number 1, I'm going to first distribute across my parentheses. So we'll have 6x is less than 6x plus 18, 6 times 3 being 18. Okay, you might also already be noticing that we're running into some sort of issue here, but let's just go ahead and get to sort of our final step. I'm going to subtract 6x from both sides, meaning on the left-hand side, I have just 0. 6x minus 6x, well, that leaves me with nothing. So 0 is less than, okay, what am I left with over there? 18. 0 is less than 18. Well, that is a true statement. True, true, true. That will always be true no matter what x might have originally have been. This statement is always true. Therefore, our solution, I'm going to write this out, the solution is actually all real numbers. We could plug in literally any value for x, and we will always end up with a true inequality. 0 is less than 18, true statement. Okay, let's look at number 2, where we actually have an equation this time. Same kind of start. I'm going to distribute negative 2 across my parentheses. Notice this negative, I'm treating that as if it's attached to the 2. So we'll end up with a 6x minus 6x, okay, minus 8 is equal to 10. All right, so I realize here that I've got a couple of like terms that I need to combine. 6x minus 6x, well, we ran into that exact thing in number 1, leaves us with nothing. We have 0 there, so I have negative 8 is equal to 10. Hopefully we're all able to recognize, nope, that's not true. We'd say this is an example of running into a false statement as the last line or last step in solving. Therefore, the solution is none. There is no solution, or we could say the solution is the empty set or null set. I tend to just write it as that circle with a line through it. Okay. So I do want to pause here for a moment and just clarify that having the solution of all real numbers is different from saying that we have infinitely many solutions. If we have the solution of all real numbers, it certainly is infinite. But we will also run into other examples of problems where we can say there's one solution, perhaps no solution like we have here, or infinitely many solutions, which we often write as infinite like this. And that is not exactly the same as all real numbers. So just keep that in your mind for now. We'll come back to that as we continue on with our pre-calculus preview here. So the other bits of information we want to cover when we talk about chapter 1 of this pre-calculus preview are just some general problem-solving techniques when we look at equations and inequalities. So the first of those being combining like terms. We saw an example of that in the previous problem, actually. So another maybe quick example we could jot down would be, say we have some expression, or let's do an equation where we have 4x maybe plus 12y minus 3x plus 8y is all equal to 20. So in order to solve, we would need to be able to combine our like terms, our terms that have to do with y and our terms that have to do with x. Okay, oftentimes we also want to eliminate groups, like eliminate parentheses, or if we've got brackets going on, things like that. This often translates to distribute. Use the distributive property. Maybe I'll jot that down here. Distribute. Okay, the next tip is a little bit long-winded. This applies when we have coefficients in our equation that are fractions or that are decimals. We want to attempt to rewrite those equations so that instead they have integer, whole number, coefficients so that we can work with them more easily. So in general, that's going to mean multiplying by a common denominator that is usually applicable if we have fractions as our coefficients, or if we're looking at decimals as our coefficients, then we generally want to multiply by some power of 10. So multiply the entire equation by 10, or maybe by 100 to get rid of those decimals. We'll look at a couple of examples where we have to do this on the next slide. So if that sounds kind of weird to you, just know that that's something we want to look at. All right, the next tip is to factor out any greatest common factor you can determine. So if there's like common multiples across all of your terms in your equation, simplify it down by maybe dividing the whole thing by 2 or dividing the whole thing by 10 to get your numbers just to be a little bit easier for you to work with. Okay, so those are just some tips. Let's try to actually apply those tips. Okay, so we've got a couple of examples. It may be wise for you to actually pause the video at this point and give these two problems a try yourself. And then maybe you could even fast forward and check your answers to see that you are on track. I will go ahead and walk through how to solve these problems, or a recommended at least way to solve these problems. So the first thing I'm going to do is distribute. I want to get rid of these different groups that I have going on in number 1. So I'm going to be distributing 2/3 across this first set of parentheses. I'm also going to distribute this negative. We can treat that almost as like a -1 being multiplied by this group of parentheses. So if we take that step, I'm just going to write that out for now. We have 2/3 times 6x minus 2/3 times 5. That's just the first group. Okay, then minus 2x. Now we are distributing that minus across to another -1/2. So we could write that as like minus a -1/2, but hopefully we're recognizing there that that's going to resolve into a +1/2. Now we haven't really changed at all that other side, so I'll just write it as 3x minus 7. Okay, so why don't we simplify this piece just a little bit? Of course, we've got our first term, 2/3 times 6x. That's just going to simplify. I mean, one way we can write that is 2 times 6x over 3, if you feel like showing that extra work, but that's going to come out to just a 4x. Okay, similar idea perhaps to our next term. We can write that as 2 times 5 over 3. That one doesn't simplify quite as nicely. That's just going to be a 10/3, so we're subtracting 10/3. Now our 2x, nothing really to change there right now, just minus 2x. But like I said, we want to resolve this minus a negative, subtracting a negative results in a positive, so we're actually adding 1/2. And that's still just equal to 3x minus 7. Okay, so I kind of want to get rid of this fraction stuff going on. In order to do that, I'm going to determine what is the lowest common multiple of all the fractions that are involved. And I only have 2 fractions right now that I have to really worry about. 2 denominators to think about. So the lowest common multiple of those denominators, or I could say the lowest common denominator, is going to be 3 times 2, or 6. So I'm going to take that lowest common denominator, LCD is often what we abbreviate that as, and I'm going to multiply my entire equation by that common denominator. So that means distributing that denominator across every single one of the terms involved here. So I need to multiply 4x by 6, and I'll do that, 24x. I need to multiply 10/3 by 6, so we'll have minus 60/3. Ooh, we can see that's going to simplify. Okay, so I'm just going to keep writing the rest of my terms all multiplied by 6 here. Okay, so I think we are ready to go ahead and simplify and combine our like terms. So of course our 60 divided by 3, that's going to result in just a 20, so we're subtracting 20 here. And our 6 over 2, that's of course just going to be a 3. So let's go ahead now and finally combine some like terms. So that means maybe I'll identify here, we've got some terms that involve x. So 24x minus 12x, well, that's just going to get me a total of 12x. We also have on that same side of the equation 2 what we might call constants, which are just terms that are not attached to any variables. We might have seen that before in a few different places. So negative 20 or minus 20 plus 3, so we'll have overall, let's maybe stick with the same color, minus 17. Okay, and we haven't really done anything to the other side of that equation yet, but I think we are ready to now. I want to go ahead and use my inverse operations to solve for x, or isolate x. So I think I will maybe subtract 12x from both sides. This part should feel really comfortable for us solving an equation once it looks like this. So I'm going to end up with a negative 17 is equal to 6x minus 42. And I'm running a little bit short on space here, but it looks like all we need to do next is add 42 to both sides. So we will get, let's see, I think 25 is equal to our 6x. And then finally, we will divide both sides by 6, and we'll write that up here. And I'll just simplify that as a fraction. So 25/6 is equal to x. Okay, let's look at number 2. Number 2 shows that we are looking at some decimal coefficients. We will see examples like this in your homework. We also have a distributive property that we could go ahead and apply. However, like without a calculator, I'm not super comfortable multiplying like a decimal by another decimal in my head. I don't love doing that, to be honest. So what I think I'll start with, just to make my life a little bit easier, is I'm going to start by multiplying by 10. I want to multiply this entire equation by 10. So that means I'm going to distribute, and I said equation where actually this is an inequality. I should be a little bit more specific there. So I'm multiplying each separate term by 10 in this whole inequality. I do want to call out before we actually do that step. Right now, the right-hand side of this inequality is one term. There are two things being multiplied together. One of those things is separated by subtraction. But because the main operation here is multiplication, this is treated as one term. So that means when I multiply by 10, I'm going to be multiplying 0.3 by 10. I'm going to be multiplying negative 1.5 by 10. And I'm going to be multiplying 0.4 by 10. But I am not going to multiply these guys by 10 because I'm already multiplying 0.4 by 10, and those things are already being multiplied all together. Okay, so let's take that step. Once we multiply 0.3 by 10, we get 3. So then we have minus 15x. So that's supposed to be less than 4 times 12x minus 2.4. So there's still a decimal involved here. Let's see if we can deal with that. I think at this stage I would like to go ahead and distribute. So let's distribute the 4 across our parentheses. That means we're not really changing the left-hand side here. We'll just copy that down. Now 4 times 12, 48x, and then 4 times negative 2.4. Okay, so 4 times 2, that gets me to up to 8, or I guess down to negative 8. And then 4 times 0.4, that means another negative 1.6. So we'll have minus 9.6 here. So you've got options at this point. We've got a decimal. We could again multiply this entire equation by 10, or inequality, sorry. We could multiply the entire inequality by 10, or we could just keep going and recognize that we've got a decimal involved. It's really up to you, to be honest. You're going to get the same answer regardless, so it's entirely up to you here. I might not multiply by 10, just show how we might work through this using a decimal. So again, once we're at this point, it looks like really I just need to go ahead and combine, not combine like terms, but use inverse operations to isolate x. So I might go ahead and just add 15x to both sides of the inequality. So that means I'm going to have 3 now is less than, let's see, 48 plus 15, 63x. And we're still subtracting 9.6. Okay, and I guess we need to add 9.6 to both sides so that we get x on just one side. And let's see, we get 12.6 is now less than 63x. Okay, and at this point, if we don't really want to deal with a calculator, maybe you're seeing like, oh, I don't really want to divide 12.6 by 63, then it may be wise to go ahead and multiply this entire thing by 10. However, if you have a calculator handy, then great, you can do either way. Maybe we'll go ahead and show, sure, why don't we go ahead and multiply by 10? If we do that, we're going to get 126 is less than 630x. So it looks like I am going to need to maybe break out the calculator or use some long division, or if you're just asked to leave your answer in fractional form, then we would just want to simplify this here. It turns out this simplifies pretty nicely. Turns out that I can simplify this all the way down to, let's see, 1/5. So we get our answer is 1/5 is less than x, or x is greater than 1/5. Those statements mean the same thing. Okay, well, I hope that gave you a little bit of practice with some things in geometry that we have been using here and there, but maybe not talking like explicitly about. That's really what this pre-calculus unit is all going to be about, is focusing now on the algebra and less on how the algebra relates to some of the geometry that we were doing. Okay, have fun, everyone.